Hello everyone, we are Team Tensor and we have been collaborating with Pacific Northwest National Laboratories to implement RMAX. RMAX is a high-level C++ interface over MPI RMA, with MPI being a message passing interface which provides a means of exchanging messages between multiple processes. Some goals of RMAX include to improve the runtime of parallel processes and decoupling communication and synchronization. Some goals for this sprint include further progress towards the completion of our futures prototype, further development on our higher dimensional testing branch, and implementing more non-generic test cases to test our futures and high dimensional branch implementations. Here's Blake for our code demo.
Hello everyone, my name is Blake and today I'll be discussing how futures have changed RMAX and yet how RMAX has stayed largely the same. One of the big goals we had with futures was to make it so that the way you write using RMAX stayed exactly the same, and so that you could still use the classic handles. We wanted futures to be optional, but become the new default. So as you can see in rmax.hpp that I have here, uh, just by toggling this, we can define whether we want to use RMAX classic handles or to use the futures. Now, onto the main meat of this. Expression elem.cpp, our oldest and most simple, in my opinion, test case. We grab a window, we fill up with ones, and then we perform some simple window operations on it. Drop those numbers into some prepared integers, and run a quick couple cheeky assert statements. Now, right in my terminal here, classic expert.out is a compilation of expression elem.cpp, but using the classic handles. And as you can see, we easily get our validation passed like we expected. Expert.out is a compilation of expression elem, but using our futures. And as you can see, we are getting the validation passed result right here, showing that despite using classic handles or futures, all you have to do is write the same code you would always write with RMAX, and it will run automatically just as is. Thank you so much for all of your time. I'll pass the hat off to Marcel now, who will go in more depth about how we completed futures.
So futures in C++ are the asynchronous programming primitive, kind of like promises in JavaScript, if you're familiar. And we wanted to use them to model any operation that takes kind of a long amount of time, like communicating between processes or doing a long mathematical operation, which may itself involve communicating between processes. And futures were the solution there, and we were able to successfully completely overhaul our implementation with futures. The benefits that come with this are pretty clear. So we get an API that can be a lot more consistent. We also get cleaner code that we ourselves as maintainers have to work with. We get a safer programming model because we don't have to use void stars and null pointers and all that other C++ stuff that can get a little bit crazy. And we also get the optimizations that any C++ compiler would use with STD futures, which, since it's part of the standard library, those could be a lot of performance or memory gains, which are quite useful in this case. As for the cleaner internal code, here we have our synchronization operation, which just makes sure that it is safe to read and write when you expect it to be. And in the old implementation, it was quite bulky and quite long, and also, as an aside, was global, so it couldn't be instanced to a specific window. It had to synchronize all windows at the same time. But in our new implementation, we were able to actually, first and foremost, cut it down, so it's a lot smaller here, about a fifth of the size in terms of lines. And it also is able to run on a single window. So you're able to synchronize one window while another window keeps doing its thing in the background, which allows users a lot more fine-grained control over how they write their RMX code. And while this is just one example, we found similar simplifications and gains across the entire API.
Hi everyone, my name is Derek and I'm going to briefly discuss some of the additional progress we made this sprint with respect to testing. When we started the sprint, there were several test files in our repository that did not include assert statements to check if the tests we were running produced the correct output. The only indication that we had that these tests were working and passing was the test file successfully compiled and ran the test code. Obviously, just because a test file compiles and runs does not necessarily indicate the code produced the correct output or in other words, the test passed. Many of these test files that lacked assert statements were inherited from our sponsor, and we had assumed that they were running and producing the correct output since our sponsor wrote them himself. However, we had no reliable way of actually verifying that these test cases did indeed produce the correct output. To remedy this, we went through each test file and added assert statements that would output the word pass in the terminal if the assert statement was successful, and if the test case was unsuccessful, the terminal would output an assert error. These assert statements allowed us to verify that our test case was either passing as expected or failing and needed a second look. An example of these assert statements can be seen on screen. The green section indicates code that was added to the test file. In this example, we fill the entire window with the number 1, and we specify a small section of the window that we want to fill with the number 3. We then extract data from the window into a list using the coordinates of the small section we wanted to be filled with the number 3. Finally, we verify that each number in the list is 3. If all numbers in the list are 3, then the terminal outputs the word pass, and we know that the test has passed successfully. As we began running the test files with the newly added assert statements, we noticed that a handful of our tests were producing assert errors. This indicated to us that the code was not running as expected and that there was a bug somewhere in the code or the test file. Through these improved tests, we were able to uncover a few bugs within RMAX itself that need some additional investigating and fixing. An example of one of these bugs can be seen on screen. In this test, we are attempting to perform simple arithmetic on data between processes of a single window. Again, we create a window and fill it with the number 1. Then, we specify a process number and area we want to extract data from. Since all the data in the window is 1, you can think of this expression as being 4 times 1 times 1, which should equal 4. However, when we ran the test case, we notice it fails because the calculation being performed is 4 times 4 times 4, which equals 64. Immediately, we could see that we had a bug on our hands that needed to be addressed. Though adding assert statements to each test case may seem like a trivial task, it provided us with invaluable data that we can use to refine RMAX in future sprints.
Retrospective. What went well? For this sprint, we improved our meeting consistency a fair amount. We've begun meeting at regular times each week, instead of deciding to meet with 1 or 2 days of notice. The length of our meetings has also increased by a significant margin. Before this sprint, most meetings only lasted up to about 2 hours, but this sprint we've decided to remove that limit, and we've held meetings up to 5 or 6 hours sometimes. This allows for greater productivity because we get our work done in these extended meetings. More frequent and lengthier meetings also means more frequent commits that we've been pushing to the repository, which was a goal of ours from last sprint. What we'd like to improve. Our use of the Kanban board is still not where we'd like it to be. It has generally been an afterthought, something that we address at the very start and ends of our sprints. Additionally, communication could definitely be improved. There were a few surprises in our group this sprint, and we'd like to minimize this if possible. Changes we plan to implement. We plan to use the Kanban board to guide our progress in the coming sprint. Instead of an afterthought, we'd like the Kanban board to guide our developments, taking a larger role for us. This also means we plan to track more issues, especially specific ones, in the repository more often than we're doing now. We also plan to coordinate efforts with our mentor a little bit more. As we begin reaching the end of this project, we want to prioritize the end user first and foremost, which means establishing rules and guidelines for how to revise the interface. This will likely require communication with our mentor.